Hello everybody, welcome to topic number 28, radical equations and problem solving. In this video we're going to show you how to solve equations that contain radical expressions, as well as using that ability to solve equations with radical expression in the Pythagorean theorem to model and solve problems. Many times you will need to use the power rule to solve equations containing radical expressions. However, you want to check that your answer because a solution may or not be a solution to the original equation. Recall from earlier in the course that we have an extraneous solution, which is a solution that is not a true solution. So, as we go through and we solve equations, our job is to isolate the radical by itself and then raise the radical to its power that will cancel it out. We know that, for example, if we have something that is squared, if we use a square root, it'll cancel it out. The same thing will apply on the inside. If we have something that's square root, we will square it and it will cancel it out. The true is for a cube root. If we have something that's cubed, we've learned that the opposite is cubing it. And so now we'll do the same here. If we have a cube root, we want to cancel it out. We will take it to the third power. Once we do that, we will solve the equation like a normal equation for x, and then we will go back and check and make sure, does the solution work or does it give us an extraneous solution? Let's model some problems here. So for A, the radical is already by itself, so nothing needs to be moved. We have a square root here, so in order to get rid of a square root, we square it. When I square a square root, it cancels out the square root, and it leaves me with just what's on the inside. So here I'm left with 2x minus 3. And on the right, I've got 9 squared, which is 81. Now I'm going to solve this for x. So I add 3 to both sides. 2x equals 84. And divide by 2. And I get x equals 42. We want to go back and check and make sure that this will work. If I plug 42 back into here, 42 times 2 is 84, minus 3 is 81, and the square root of 81 does give us 9. So this is an equation that works. Here on B, the radical is not by itself. We want to get the radical by itself, so I need to take this 3x and move it to the other side. So I will subtract the 3x over here. As I do that, now I'm left with the square root by itself, and it is equal to negative 3x. I'm going to get rid of the square root by squaring it, but whatever I do to one side, I'm going to do to the other. When I square the square root, it cancels and leaves me with what's left on the inside, which is just negative 10x minus 1. Over here, negative 3x squared is the equivalent of negative 3x times negative 3x. Negative times negative is a positive 9, and then 3x times x gives me x squared. Now I can solve it. I see that I have a squared here, so I know this is going to be some sort of quadratic, which means I'm probably going to need to use a factoring technique to solve it. If I want to use the factoring technique, I need to get one side equal to 0. I'm going to go ahead and keep the positive 9x squared here because it's already got a positive 9x. And I'm going to move these parts to the other side. By moving this, it now makes this side 0. None of this is like terms, so 9x squared plus 10x plus 1. I have 3 terms here. My biggest term is a 9, so I know that this is going to be the AC method. I need to find something that multiplies to a times c. So 9 times 1. It has to multiply to 9, but add up to 10. Well, the only thing that multiplies to 9 that can make 10 is 1 and 9. And both of these would be positive. I'm going to rewrite this as 9x squared instead of 10x. I'm going to do 9x and 1x. Then I'll drop down the 1 here. And now this is 4 terms. So I can go ahead and do group factoring here. From the first group, I could take out a 9x, which leaves me on the inside with x plus 1. In the second group, there's nothing really to factor out here except a 1. And on the inside, that leaves me with x plus 1. I know everything is good because the parentheses here in red are exactly the same. So this will become 9x plus 1 and x plus 1. And now we're going to take these and set each of them equal to 0. So x plus 1 equals 0, and 9x plus 1 equals 0. Subtracting 1 from here and dividing by 9 leaves me with one solution to be negative 1/9, and the other solution to be negative 1. Making sure we go back and check our original. If we plug in negative 1/9 here, we would see that it would work, and this would come out to be 0. Same thing with the negative 1. You should just be able to plug in those values each at one time to this and see that you are able to get 0. Both of these solutions would end up working. Again, we don't have the radical by itself, and right now it's a cube root. So we want to subtract 5 from the other side. So I have the cube root of x plus 1 equals negative 2. My job is to get the cube root by itself, so I need to go through and take it to the third power. But whatever I do to one side, I'm going to do to the other. Here the cube root and the third root can cancel out, and they just leave me with the inside. I have x plus 1. Negative 2 to the third power is simply negative 8. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. I subtract 1. I get x equals to negative 9. Going back in and plugging this in here, negative 9 plus 1 is negative 8. Remember, we can take the cube root of negative 8. We can't do the square root, but we can do the cube root. The cube root of negative 8 is negative 2. Negative 2 plus 5 gives me 3. So this is a good solution here. Now in this problem, again, the radical is already by itself, so we're going to square this side, but we're also going to square this side as a whole term. Now on the left side, the square root just goes away when I square it. It leaves me with 4 minus x. But this is x minus 2 squared, which is the same as x minus 2 times x minus 2. When you square something, you multiply it by itself. Foiling this out, I have 4 minus x still over here. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. I can combine like terms there. So I have x squared minus 4x plus 4. Again, I see that it's squared, so I'm going to need to use some sort of factoring term. So I'm going to subtract 4 from here, and I will add x to here to make this side 0. X squared negative 4x plus 1x is negative 3x, and the 4 minus 4 cancels. So I'm left with just x squared minus 3x. It's two terms and a minus sign, but 3 isn't a perfect square, so I can't do difference of squares. I do notice that both of them have an x, so I'm going to take out a GCF of x. When I factor out the x, I take away an x from each term, I'm left with x minus 3. Nothing else left to factor here. Each one of these gets set equal to 0. You're telling me 0 is a possible solution. And over here, 3 is a possible solution. Let's go back and check it though. So if I take the value and I plug back in 0, I get 4 minus 0 here, which is 4, and the square root of 4 is 2. But when I do 0 minus 2 here, I get negative 2. So understand, I plugged in 0 and I got 2 equals negative 2, which is not true. This is an extraneous solution. It does not work. It would not be included as part of our answer. If I go back in and plug in 3, 4 minus 3 is 1, the square root of 1 is 1, and 3 minus 2 is 1. This one does work. This would be the only solution that I have. So that's why it is important. We have to go back and make sure we plug it in. If you're not going back and checking it and you're putting in both answers, you will end up getting it wrong. So please make sure when you find your solutions, especially if you find multiple solutions, go back and check and make sure all of them work. Now in this problem, we have multiple radicals. Again, our job is to get one of the radicals by itself. So I'm going to get this first radical by itself by subtracting the square root of 2x to the other side. That'll cancel this out. That leaves me with the square root of 2x plus 5 equals 3 minus the square root of 2x. We're going to square both sides, and here it will cancel, and it will leave me with 2x plus 5. But over here, we have 3 minus square root of 2x written twice. Remember, anytime you square something, you're multiplying it by itself. We're going to FOIL out that right side. 3 times 3 is 9. 3 times negative square root of 2x is negative 3 square root of 2x. 3 times negative 2x again is negative 3 square root of 2x. And then when you take a radical and multiply it by itself, the negative times the negative is a positive. Square root of 2x times the square root of 2x just cancels out the square root and leaves me with 2x. Before I go any further, I notice that in the middle I have like radicals. They both have a square root of 2x, so those will be able to combine. So I've got 2x plus 5 equals 9 minus 6 square root of 2x, because negative 3 minus 3 is negative 6, plus 2x. Now my job is to get this radical by itself. I want to try to undo things. So the first thing I'm going to do is I'm going to move these two things to the other side. That'll cancel out this and this. The 2x minus 2x also cancels out. So in this case we have negative 4 is equal to negative 6 times the square root of 2x. Now this is negative 6 times square root of 2x. How do we get rid of multiplication? We divide. So these cancel out. I'm going to move this over here. And this is square root of 2x now. Negative divided by negative is positive. That gives me 4 over 6. 4 over 6 we also know we're reduced to 2/3. And now my job is to get, again, the square root. Now that the square root's alone, I can get rid of that by squaring both sides. In this case, when you square a fraction, you square both the top and the bottom number. So 2 squared is 4, 3 squared is 9, and now it just simply equals 2x, because the squared and the square root cancel out. I need to get rid of a multiply by 2, so I'm going to divide by 2. Remember, when you divide by 2, it's really multiplying by a half. You're just skip, flip, and multiplying. That leaves me with 4 over 18, which reduces to 2 over 9. Again, you can go back in and plug 2 over 9 into both of these, and you would find out that it does equal 3. So make sure you check your solutions. If you have multiple square roots, your job is to get one of them by itself and eliminate that one, and then try to then work everything else back to the other side and get the other square root by itself. Finally, the other thing that we can work now is the Pythagorean theorem. Probably most likely you've seen this in a geometry class before. This is what we use to find the lengths of right triangles. If A and B are the legs of the right triangle and C is the hypotenuse, then A squared plus B squared equals C squared. Remember, the legs are always next to the right angle, and the hypotenuse is always directly across. And C is always the hypotenuse. A and B can be either of the legs. It does not matter which. In this case, they want us to find the unknown leg, which we're calling B. So we will call this A, and we will call this C because it's directly across from the right angle, so that means that is the hypotenuse. So if A squared plus B squared equals C squared, then 4 squared plus B squared will give me 10 squared. 4 squared is 16, plus B squared equals 100. I'm going to minus 16 to the side. I have B squared equals 84. And now to get rid of the squared, we square root. So I have B equals the square root of 84. Now we know how to simplify, so let's check and see, can this simplify? I know that 4 can go into 84, and it can go in 21 times. 4 becomes 2 times 2. 21 becomes 3 times 7. It's a square root, so I have one group of 2's. That comes to the outside. The 3 and the 7 go back inside, and it makes 2 to the square root of 21. So in this case, we're using this idea of the Pythagorean theorem, and we're solving for it. But now we're not writing our answers as decimals. We are writing them as square roots and then simplifying them as we need to.